Okay, thanks everybody. We have started the recording and I am going to share my slides here. There we go. All right, so this is a virtual meeting for talking about MPI Big Count. We've been very hard at work on a lot of things to try and make this real before the September meeting. By the way, just for the video, my phone is over here and my computer is over here. And I'm thrilled to notice that I have a typo on my first slide. That is fantastic. After proofreading this 1,000 times, still had it there. There we go, fantastic. So when I'm looking over here, it's because I'm looking at my computer. That's why I keep looking off to the side over here. So we have had a two-pronged approach for Big Count here. So we've kind of split the working half in group, even though we're working closely with each other. Martin and I have been working on the LaTeX and some technological things, and I also sent out the Frusel sample implementation for Big Count that we encourage everybody to look at. I don't have a link to that today, but I can put that in the slides that you'll all see later. That is where we did a lot of the proof of concept, making sure that C11 generic works, that C++ function overloading works, that Fortran interface overloading works the way that we expect, and it can be done in the way that we need for PMPI, that it's realistic for MPI implementations. What exactly does it mean for the _x functions that are already in MPI 3.1? It was a really good vehicle for that. We encourage people to go have a look at that stuff and play around with it and let us know if you find any issues. That's exactly what it's there for. It's out on GitHub. Feel free to have a look. Today, we're going to mostly talk about two things. One, rendering the bindings in the document, which sounds kind of mundane, and it is, but there's unfortunately some big issues that we need some feedback on from the forum before the meeting in September. And then two, we have a first cut of our text that we would like to run by all of you here and get feedback before September as well, because it's pretty symptomatic of our overall approach. So let me jump into that here. Let's remind you of the decisions that have already been made. These were made at the last meeting in Chicago and Chattanooga as well. So it's been kind of we're in the third meeting of a sequence here. So one decision that was made that we're really only going to do Big Count fixes for C and the MPI F08 module. We are not doing it for the older mpif.h header file, and we're not doing it for the older MPI module. So it doesn't mean anything about those two older interfaces. It just means we're not going to have Big Count in those. If you want to use Big Count, use one of the, use either C or the good Fortran interface, not one of the sucky ones. We're also not going to make any normative explicit mention of C++. There are C++ ramifications to this, and we'll get to that in a minute. But MPI 3.1 does not mention C++ support at all, except for the deprecated and removed stuff. Actually, no, I'm sorry, it's already gone. It only talks about C and Fortran, and this ticket is not intending to change that at all. We do have an advice to implementers about MPI.h and C++, but that is not normative text. And we'll show you that text when we get there. Now, there's 5 decisions that we need your help on here. What suffix should we use for the C bindings? What suffix should we use for the F08 bindings? How do we want it to look throughout the text? How do we want it to look in Annex A? And should we also do displacements at the same time that we're doing count? And I'll go into detail in each of these. So the first one is relatively simple. What symbol suffix should we use for the C bindings? We really do need to differentiate these from the 3.1 bindings. Now, don't forget, we actually have about a dozen or so MPI 3.1 bindings that have an _x suffix already, and those use MPI count. They were specifically added as a minimum step in MPI 3.1 to get correctness. Because if you recall what happened in the 3.1 timeframe, we didn't know what the right answer was, but Jeff Hammond convinced us all, and I think correctly so, that, hey, these are the minimum ones that you need to be able to do big count. So let's just do these underscore X ones while we continue debating about what is the right, proper, complete answer for big count. So then that comes up to here. We're talking about MPI4 here, and if we're going to do something that adds in a whole bunch of more symbols, which suffix should we use? Because we clearly can't change like MPI send, that symbol already, that's already tied to int. But if we're going to have an MPI send with an MPI count, which suffix should we use? And two important disclaimers here. Users are not going to see this suffix, right? This suffix is really only for implementers and tool authors. We're going to tell users to just call MPI send. And we have C11 in generic, and we have C++ function overloading, and we have Fortran interface overloading so that they don't have to actually see the suffix. Now, the three options that we came up with, and honestly, we could pick any suffix we want, but we just wanted to give you three options here, was number one, just keep using underscore X. That has the minor downside that it doesn't really distinguish it from what happened in 3.1. The second one is to use underscore L for large. And this is kind of the one that is our personal favorite because it's different than MPI 3.1. So you can clearly say, oh, these were the dozen or so functions that were added in MPI 3.1. These are all the new ones, and there's about 130 or so that were added in MPI 4. And of course, we could do something else like BC for big count or something, or even ... anything else. And so I'd kind of like to take a straw poll here on the forum. And Martin, I wonder if you could record this for me since I'm doing the talking and I'm presenting here. How many people would say they would want to continue underscore X? And you'll have to unmute yourselves and say something.
Jeff, can you hear?
Yeah. Yes.
We have never attempted or thought it was a good idea to distinguish when we added a feature set with any attribute in the name, including we didn't do anything. You know, it's not like we have MPI win flush underscore 3 or whatever, or underscore F for fixed. Why would we do this now?
Because we have to for C11 generic.
No. Why would we choose a different name besides the one we're using in MPI 3.1? What is the value in visually telling people this is when we added this feature?
Oh, I see. Okay. Well, keep in mind, this only applies to implementers and tool authors. Users are just going to call MPI send, right? So this is more about implementation than interface.
So
right?
I dispute that because I am not certain that all the C compilers in the world default to C11. But most of them, until the GCC and Clang default to C11 and did so relatively recently, many other compilers default to C89.
Sure.
So
we have similar text. Okay, so we're jumping ahead in the presentation here a bit, but we have similar text saying, hey, if your compiler doesn't support this, then you just don't get big count, just like we did for Fortran 08. Right? When we introduced the MPI F08 module, we said, if your compiler doesn't support it, then great, you don't have to have it, and you can still have the check mark that you are MPI compliant. So similar here, if your compiler doesn't support C11 and doesn't have underscore generic, cool. You just don't have a new version of MPI send. So
no, okay, so I'm ferociously opposed to this. We have to have the symbols because here's the thing. What you basically said is Petsy does not get this, okay? Petsy's not going to depend on C11, and there's absolutely no reason why they should. They should be allowed to use the actual underlying symbol that is perfectly valid for use in C89 inside of their library so that their library remains widely compiler portable, and none of their users give a damn because their users don't call MPI, they call Petsy stuff.
Okay, so Jeff, you're now arguing both sides. You're saying, why do I need to add a suffix? And now you're saying, but I want to use the suffix.
No.
So which one is it?
No. I'm making two arguments, and they're the arguments that I have made since forever, which is, one, we absolutely must have an explicit symbol for C89 and other compatibility reasons. And second, I am arguing a less important point is that I see no reason to not use _X in order to tell people something that they don't need to know and we've never tried to tell them before.
So the latter argument, I think we should just stipulate is fine and use _X and go back to the harder argument.
Well,
Okay.
there actually is, there was a technical problem using _X that we discovered in Frusel, right? There was, which case was it? Martin, can you remind me, do you remember what exactly was the problem?
Get elements _X.
It was get elements, yeah, it was one of the existing _X ones that in order to upgrade it, we needed to add an X, but there already is an X. And the X is not the same as the, upgrade both. And that's why we came across the oh, okay, let's use a different suffix like _L.
Here's the thing. So does that function take a vector pointer argument or a scalar argument?
I'm going to have to pull this up now.
I'm going to tell you right now, I'm 98% certain it takes a scalar. So what we should do for consistency, rather than add a whole new naming convention, confuse the hell out of people, we should fix that function and say, that was a screw up. We're going to erratum it. Nobody except me and 3 other people in the world are using it. And if it takes a scalar from C and C++ languages, it won't mean anything. It won't even be a problem. So the only code that would ever be broken if we fix that function is Fortran code that is using MPI3 get elements _X. And I just don't believe such code exists.
It does take a scalar. It's an out, but it's a scalar.
Okay,
right.
so you're right.
That is one possibility. We took the approach of not breaking backwards compatibility at all.
What's wrong with the function?
If you want, okay, so if we quote unquote upgrade MPI get elements, that means that there's going to be 2 Fortran interfaces, MPI get elements and MPI get elements X, right? But MPI get elements X already exists as a standalone function, so you can't do that.
Got it.
So it's only a problem in Fortran 2008.
Correct. If I recall correctly, correct. Martin, please correct me if I'm wrong.
Then it's basically, it's not even a very small problem. It's an even smaller problem. How many people even today have Fortran 2008 compliant, like actually seriously, not just academically compliant FO8 bindings?
I think OpenMPI and MPIG both do, right? I think the only thing that we're a little skimpy on is I forget the frickin' name for it. When you do the new void star, you can actually pass a descriptor instead of a buffer.
But how many compilers? I know that libraries are pretty good at this, but what about the compilers? Because if you're telling me we're only worried about Cray systems, we're talking about taking
GCC, G-Fortran has supported this since like G-Fortran 7 years now, whatever it is.
So in fairness, before you allow this whole virtual meeting to be derailed, can we take it under advisement that one of the possible solutions also is that we suppress this function completely, and then the new solution gives you the 2 versions of it. So there's another solution: you delete this function, and then you get it the new way, and you get the same thing you had before, and everyone's happy. I would just, and with reference to both Jeff's, let's let Jeff Squires get through the majority of the points. Maybe we could save up some of these things because we really worked diligently to get this done, and we respect all the Jeff Hammond concerns because you know the most, okay? But I think we can come up with an elegant solution for this one without losing the whole hour.
Fair enough.
It's going to be all the _X functions, by the way.
Right.
It's
so
not
maybe
going to be just get elements X.
Okay. So here's my strong proposal, which you can shoot at later asynchronously. We remove them all. We put them all back in the right way because no one's used them except special cases, and then they get them a new, better way, and we win.
Yeah, I suspect that will be a contentious conversation. But you're right. If we could get through the rest of this, but that is a very important point we'll get back to. Cool?
Cool. Thank you.
Cool. Jeff Hammond? I'll
said
take
myself.
your silence
That's
as a
my
yes.
sign of approval.
Okay, keep going.
Gotcha. All right. Well, that notwithstanding, what suffix would people like to see? And again, this is a straw poll. It's going to become easy to change over time, as you'll see in a few minutes. But who would like underscore X? Like basically continue what we did in 3.1. If you could unmute yourselves and give me a verbal yes.
X.
I guess that was one.
Then X.
I'm sorry?
If it can be made to work, then X. If it can't,
Okay.
then L.
Okay, so that's 2 yeses for X. Okay, how about underscore L for large?
Yes.
Okay, I like underscore L. Can you guys hear me?
2?
We can
Yep, got 2.
Oh, good.
Got Jim there.
Hey, Jeff, I was going to go for underscore X. This is Puri here.
Okay, 3 for X, 2 for L.
This is
All right,
Catherine.
how
I
about
like L.
BC? 3 for L, okay. Who wants BC?
I probably prefer L. This is Rich.
Oh, there we go. We got a 4th for L. If anybody wants BC, I'm going to actually have to shoot you. We put it in there just so we'd have a 3rd option. It's pretty terrible.
You need an AD too if you have a BC. I think you can go with Al and continue. Why don't you continue along with Al and keep going?
All right. Anybody else care about any other suffix or have a brilliant idea other than X, L, or BC? Okay, so we got 4 for L and 3 for X. Cool. Next one is similar, but for FO8. And remember that FO8, we already have a mandated underscore FO8 suffix, right? So the obvious option is just do whatever is chosen for C and then follow it by FO8. Or screw whatever you did in C, just do X, just do L, just do BC. How many want to do follow what we do in C?
Yeah.
Follow what you do in C.
Yep, plus 1.
3?
Yep.
4?
Yeah,
5?
the same.
6.
Yeah, just
6?
as a, just
Yep.
a comment.
7?
What happens with get elements X in Fortran FO8 now? Is it underscore X underscore FO8? In which case, that makes the decision for me.
All right, hang on a second, Dan. So we got 7 for that one, and Dan's vote is pending. Who wants to just hardcore go with underscore X?
Yes.
0. Hardcore go with underscore L. Hardcore go with underscore BC. Okay, Dan, this is exactly the problem. Let me bring this back up to the screen here. There you go. With underscore X in Fortran, it is a problem right now. That's why we came up with underscore L, right? But Jeff Hammond is floating an additional proposal saying, well, why don't you just get rid of the old broken one, and then you don't have this problem.
Mm-hmm.
And that is something we can talk about. That is not the approach we took. We took the approach of preserving backwards compatibility, but that is certainly a valid approach we can talk about.
So at the moment, the function you've got here and highlighted in Fortran, you would have an MPI get elements X in the module, but in the FO8 module, you'd have MPI get elements X FO8 because it's mandated to have FO8 on the end of all of them.
Oh, I'm sorry, I misunderstood your question. So today, like MPI 3.1 implementations, that is correct. There is an MPI get elements X underscore FO8 symbol exported by the module.
Yeah, that's the if we can make the X thing work for C, then we can make it work for FO8 in the same way because we already have the symbol. If we can get rid of that symbol and reuse it for some other use, then we're done. But it's the same answer as the previous one. If we can make it work for C, then it will work here as well. We should use the X, you know.
Okay, C is not the problem. It's Fortran that's the problem.
Yeah. Okay. In which case.
Okay.
It's the same answer as before. If we can make it work, then the X.
Okay. Okay.
Jeff, I had a question from something you said a couple of slides ago, and I was just looking at the Frusel code to try and answer my question. It looks like the _L function prototypes are filtered out of the header when you don't have C11 support. Is that right?
Correct.
Why would you do that?
That was the approach we took, yeah, that if your compiler didn't have generic, then you just didn't get those symbols at all. This idea that...
You still have the symbols, right? You're just filtering out the function prototypes. I mean, my question,
sure.
If you have a C89 compiler, you can call those functions.
Right.
The only
Our
thing we should
whole
filter out would be the
approach
generic
is different than what Jeff Hammond had said, was that our whole approach was the users never call MPI send L or underscore send X or whatever. They always just call MPI send. And if you don't have the, the new stuff, then you don't get to call MPI send with a big count. We frankly had gotten, well, hold on a second, let me finish. Let me just tell you how we got here. We can change this, but this is how we got here. The feedback we had gotten was that we did not, from the forum, was that let's not introduce underscore whatever and have 1,000 new things that users can call. We just want them to call MPI send, and the right thing should happen under the covers. This is a new data point today, at least that I am hearing, because Jeff hasn't been to the last 2 meetings, saying, no, I do want it to be able for libraries who don't want to require C11 support to be able to call MPI send underscore whatever. So that's how we got here, Jim. So I'm sorry, I interrupted you. Please say what you were going to say.
Yeah, I mean, I think we should add the feature and not require users to use C11 generic selection to get at it. And then beyond that, I mean, we've got tools that will want to implement these functions as well, right? And if I'm compiling the tool with a particular compiler, I'm just thinking, there could be situations where maybe the compiler you're using for your profiling tool doesn't have C11 support switched on, and so it's going to screw up all of the all of the profiling books you're trying to generate.
Yeah, here's the other point. This only saves effort in LaTeX, which is something that we can automate. This doesn't actually save any implementer any effort, because in order to support the tool, they have to build the symbol, and they damn well better put a tools header in there that actually type checks, so the tools actually can get compiler type checking, So I don't understand what we're saving here. I mean, we'll save Rolf some paper.
It's a bit of a head.
That wasn't the issue. The issue was simplicity for the user, right? That you call MPI send. And again, if we want to change it, great. I'm just telling you how we got here was that the user doesn't have to know if they're using big count or not, or which symbol to call. They just call MPI send, and the right thing happens.
And Jeff,
that was the overriding.
That is an absolutely wonderful feature that we should provide to people. I'm just saying that not having the underscore explicit symbols in the API is literally just giving the middle finger to a bunch of people who don't have a C11 compiler, so that we don't have to add some paper and some LaTeX. The trade-off is horrendous. It makes no sense.
I didn't understand that, though. I didn't understand that it isn't in the way I've been working with Jeff in the background, is that we have those things are enumerated in the appendix A2 and in the index in the back.
Right.
What
Jim is citing is that in Frusel, I did actually comment those declarations out in MPI.h if your compiler does not have C11 generic. So I think the distinction that they're making is that an implementation should always have these symbols. And if you have generic, you also have the generic stuff. But if you don't have generic, your only option is to call these symbols explicitly.
Right. So I guess I'm siding with the 2 guys that saying that I don't see any danger in the symbols existing.
Yeah, I don't think I do either.
Do we specify what
actually,
the default
that's a
should
better
be?
way to say this. I think we're all violently agreeing I'm just telling you how we got here, but I don't think we're opposed to saying, okay, these symbols will always exist and they will always be in MPI.h and the module, blah, blah. You may have the C11 generic auto selector if your implementation supports it.
So another question is, do we specify the default case in the C11 generic clause?
Yeah.
Okay, good. I'm concerned that I could break the default
I'm sorry,
case.
Hold on. Frusel did. We do not have any text about that in the spec that we're going to show you here. We just said that there's two interfaces. One with, here's a spoiler on the text that's coming up. There's two interfaces. One is the old MPI 3.1 interface, however that was defined, because some of them were MPI count already, but many of them were int. And then the new one is all MPI count. So like for the collectives that have multiple count arguments, they're either both MPI count or they're both whatever they were in 3.1. There's no mixing and matching, so to speak.
So I think you're going to
make it normative, and then we can decide if you can break it. Let's actually make the thing a statement of advice. Let's make that piece normative, how those have to work.
Yeah, you really want the default case to have some consistent behavior across implementations, because I can specify literals, for example, in C that don't match either int or your MPI count type, right? And those are going to land in the default case, like if I put a UL constant in there just to be a jerk. Right,
okay,
and
that's a good point.
If you leave default undefined, then the user gets a type error. Otherwise, it falls through
right.
to another function, and something funny happens.
So let's agree on the.
No, you're citing something that we figured out in Frusel and forgot to put in the text. So that's very good feedback. So Martin, I am nominating you to take that point of feedback. Thank you.
It's good feedback. Thank you.
Yeah. Not only am I nominating Martin because he's our requisite grad student, his microphone is also broken, so he can't tell me no. So that's fantastic.
So I'll say yes for him.
Yeah. Thanks, Jim.
Even worse. Yeah. Okay.
Okay. All right. Next one. Let's talk about rendering the bindings in the text and the annex. So Martin and I have actually spent quite a bit of time revamping the .tech. Although this is still a work in progress, we fully updated the point-to-point chapter, and that's what we're going to be showing you here. This is essentially a ticket 0 level change because the rendered output is essentially the same with a couple of caveats. But here is a link to the GitHub pull request that you can see. But here's the gist of it, right? This is how the LaTeX is in MPI 3.1. This is what we've changed it to. That there is just one. You only have to specify the function name and the parameters and the types and the descriptions and whatnot. And from this gets processed by a Python script to generate the appropriate LaTeX for all the bindings in the document. So the language neutral, the C, the quote unquote F90 bindings, and the F08 bindings. This is tremendously simpler for the LaTeX author. Now, there's a couple of caveats to this. There are some minor changes compared to what happened in MPI 3.1. For example, the star in the C bindings is now consistently to the right. We can change it to be consistently on the left. We don't really give a damn. We just had to pick one, and we did. But throughout MPI 3.1, sometimes it's on the right and sometimes it's on the left. The order of lines of Fortran parameters might be slightly different because we picked an algorithm of how to group the parameters. And in MPI 3.1, humans were not always completely consistent about how they ordered the parameters. And the indenting may be different. So for example, there's two examples there on the bottom. That's how it looked in MPI 3.1. Here's how it looked with our Python script. You can see we chose a different splitting of the integer parameters. For example, we didn't concentrate all the integers into a single line. We could. We don't give a damn. This was just our first shot at an algorithm. If people have violent allergies to the algorithm that we did, it's easy enough to change. So there's minor discrepancies like that that do not affect the semantics at all, but it is not a byte-for-byte comparison against MPI 3.1. Now, with these changes, life is really significantly simpler for LaTeX authors. one side effect of this is that when doing readings and you're like, oh, I hope my Fortran bindings are right. Hopefully somebody will proof those for me, but I'm going to skip over it here in the bindings. That will be significantly diminished. I'm not going to say it's going to be perfect because nothing is ever perfect, but wow, you just type in, this kind of thing, and you get all 4 bindings for you made automatically, which more than likely are going to be correct. That's pretty awesome. Right. And over time, we can also change this Python script to emit the bindings however we want to. And as I said on a previous slide, of course, we're working with Bill Gropp on this. Bill Gropp is in favor of this. We're iterating back and forth to make things the way that we want them. But he's in favor of automation like this. All right. Now, there's a little more to it than that, of course. There are some corner cases like to handle IR and some procedures that don't return int and blah, blah. But the vast majority of it are as simple as the one I showed in the previous example, and we're going to fully document it and whatnot. Now, this does have the side effect, and I'm sorry, it will make existing pull requests be stale because you'll have to go back and redo your bindings, and I'm sorry about that. But honestly, in the long term, things will be significantly better after this change. Right. Now, with that, how do we want the rendered bindings to look throughout the text? Right. And we came up with 3 different options here. So the first one we're calling explicit, that we show all the bindings. And this is in the text. So like where we define MPI send, for example. So you see MPI send and then MPI send suffix. Or we could show fake, where it's kind of polymorphic. We show MPI send with int and then MPI send with count. Or we could have a token-based approach where we emit a single MPI send and it has a token in there for the type. And this is why I sent out the link to these slides, because you can look at these PDFs yourself. I am going to pull them up here, but please feel free to pull them up yourself at home. So so I'm going to pull them up here.
So Jeff,
yeah,
I had a question. I guess I don't have a huge strong opinion, but I would like to understand what people think is the priority, because basically the answer to which binding we choose is really, should be determined by what thing we are trying to optimize for, whether that is a certain level, one definition of usability, page count, Rolf's paper utilization, what do people think the goal of the bindings is?
I think page count is irrelevant. I think you and I are in the same sheet of music on that one. We don't care about that at all. But we need to make a choice for a pull request, and that's really what we want the feedback for. Now, if we go with this new requirement of like, no, we really want to show the bindings and let users choose which one they want to call, then that lends in a certain direction. It sounds like you're on a phone. I don't know if you can see what's on the screen right now, but I do want to show all 4 of these, and I think that will help shape the discussion. Yeah.
Okay.
So here's what we've got in MPI 3.1. This is before Martin and I changed anything. So this is just for comparison's sake. Now let's look at explicit. And this is where you can see, all right, we have the same old language neutral, but now there's 2 C bindings. There's MPI send and MPI send L. And again, the suffix is irrelevant. We can change this was rendered with L, but it can be X or BC or whatever we want it to be, right? And then in the Fortran 90, you can see there's also an MPI send and an MPI send L. And then in the old mpif.h, there's also an MPI send and an MPI send L, right? This one, of course, does consume more pages. Don't really think that matters, though. All right, so this is what we're calling explicit. Then we have what we call fake. And that is where, again, we were going with what might be a bad assumption, the polymorphic approach. that yes, I have two MPI sends, but they're both MPI send. One of them has an int count and one of them has an MPI count, right? So this is exactly the same as the previous one, but the suffix is not shown, right? And again, I've got two Fortran 91s. One has count as an integer and the other has count as an MPI count kind. And then the same thing in the MPIF.h, count is an integer and count is an MPI count kind. So the only difference is whether we show the suffixes or not, right? And then the last one is what we call the token-based approach.
Hey, just a quick question on the one you just showed. Are those suffix functions specified somewhere, since they'll need to be implemented by tools?
Yes, we have some text describing them.
I see. Okay.
All right. So remember, there's two questions here too, right? So this is just the first question of how do we want it to appear in the text? How we want it to appear in Annex A is a related but different question. Right?
Gotcha.
So for the moment, this is just text. All right. And so the last one is token, and it looks like this, where we go back to having just one binding for C, one for Fortran 90, one for C, and we picked this, Waka count Waka, but we could use any token we want. And we have some text describing like, oh, when you see this token, it means there's two bindings. One is of type int and the other is of type MPI count or the Fortran equivalent kind of thing. This is the most compact. It's the most green. But again, we don't care about page count because how many people are actually printing this out?
Now, are you taking feedback yet?
Sure.
So the thing I like about the token is it means that we would not have to make an order n change if we ever decide for whatever reason to add to the types that are supported by the polymorphic interfaces.
Yeah.
And also, and this is a separate ticket but if we were to allow implementations to define additional tokens, as in we were to say the MPI standard requires that you support int and count, but implementations are allowed to, and in an whatever, text to be determined later, add extra tokens for whatever reason they choose to do, then that would also be supported as an order one thing. And I could see there potentially being a value in implementations having extra tokens if their users, aka customers, just find something obnoxious and they want to push the easy button and make the customer problem go away rather than trying to change the MPI standard to fix it.
Yeah, that's true. They want to use UN48 for whatever reason. Yeah.
Yeah, exactly. Just insert stupid reason that we all know users do.
Well, there's actually the second part I agree is good pragmatically. The first part is interesting because we want to add info arguments some places. That really changes how we approach those tickets and stations about where we think we need to have like with info, which also Jim has introduced in some places earlier. It's a very interesting point. I think we should come back to that in a future discussion. And now with polymorphism, we can go ahead and add the info arguments wherever we want them.
I think, Tony, that's a very, very different type of thing because C11, you can't use C11 generic like C++ templates.
I agree. And I didn't mean to digress. Sorry, I'm going to stop.
Okay, just to emphasize, these three PDFs that we're looking at with the different rendering styles were done with the Python thing, right? So we had that very compact listing in the text, and we changed the command line parameter to have the Python emit LaTeX in 3 different ways. So it was fully automated once the conversion had been made. So that was very pleasing. So yeah, this is just kind of the feedback that we're looking for, like which style do people like? So what are some other opinions here? We just heard Jeff talk about the token one. What do other people like?
I personally would want to see not just the macro here, but the C functions, right? The MPI send underscore L. It does make
So
me.
this one.
Yeah, but you're still missing one there, right? Because you don't have the generic MPI send.
I do. There's MPI send and MPI send L.
Right, but MPI send takes int count. You also have an MPI
Yeah.
send that takes MPI
Right there.
count.
Well, according
Oh,
to the C11 generic, it'll actually be dispatching off to MPI send L, right?
Maybe I'm misunderstanding. I mean, I'd expect to see a third one here, which says MPI send and has an MPI count argument. Am I just looking at it and not seeing it? Is that
No.
what's the bottom Fortran?
The bottom two there are Fortran, yes. So there's just from 35 to 39 here are the C ones, right? That MPI send as a symbol without a C11 generic selector will only take int, right? And MPI send L will take MPI count. So if you want to explicitly call MPI send L, you have to call with count or something promotable to count.
So this goes to
I'm sorry to.
What are we optimizing here for? If there are three ways that the user can call send. If we have send L as an explicit symbol here, then there are three ways the user can call send. They can call send with an explicit int parameter, and it will call the first one. They can call send L with an explicit MPI count parameter, and it will call the second one.
Oh,
or
I
they
see
can
what you're saying.
MPI send with an explicit 8-byte, MPI count parameter.
MPI count.
Use generics to call the send L one, but it'll look like they're calling send. So there are three ways the user can call send here.
Okay, that's a fair point. We didn't take that into consideration.
Yeah.
Jim, is that what you're trying to say?
Yeah, that's well said, Dan.
Okay.
Better than
Okay, that's a good point. We hadn't thought of it that way, but that certainly, I guess we would lump that under explicit.
You've got three things, right? You've got an MPI send function.
Yeah.
You've got an MPI send macro, and you've got an MPI send L function. And actually, I would really request that we have a feature macro in the MPI header to disable the MPI send macro. And the reason for doing so is that it aliases the function. If you alias the function, you can't take a pointer to it. And we do have some users that would like to stuff a function pointer for a send into a structure somewhere.
It's not a requirement of the standard. That's a new requirement that that names of functions be explicit pointers. That's come up already in the discussion group. I think you're asking for a new feature of the standard. It wasn't previously guaranteed because it can be completely pre-processed. I think it's a new semantic requirement for the standard. It's nowhere documented. I agree. I like the idea. Sorry, but I think it's new.
So Tony, tell me how we would do the profiling interface if there wasn't a function pointer.
Naming the symbol and having a function pointer to the symbol are two different things, right? Why can't I just name the symbol whenever I want instead of a switch statement?
I guess I would say that your argument that function pointers haven't always been very clearly implied would violate the principle of least surprise. We often discuss these academic things about these magical implementations.
Jeff, we're losing your audio.
I know, but when you argue the other point of the point, when I
through a
think
bridge.
that things are obvious, you got mad at me a few weeks ago. So I just point out it's not written in the standard that function pointers are there. Either we have to write it or you can't assume it. Because we have this argument that you took the opposite argument recently on some other very fine point about typing and so forth. So I think it's having a header.
We do have.
I suspect there are users that have made this assumption, and we probably shouldn't go break their code with this change. We should give them a path that still works.
Okay,
we have
well, then
there already that says only certain things can be macros. W time and W tick and things like that.
I agree.
I think we're all violently agreeing here. I think Tony is just correctly pointing out that this is not currently guaranteed in the spec. I don't think anybody's opposed to it. I think that's a good suggestion from Jim that we should have a way to turn off the C11 generic selector if desired.
I think the C11, we're trying to do our best for C11, which now looks like a crippled language, but we found something we could do. So we thought we'd do it, and I realized the rest of us still use C89 like thinking, but we were hoping we could make it prettier for C11 in case there are some users. And it is, after all, the God-given standard now. And so, we're trying. It's a stretch, but it seems to work. So all these other side cases notwithstanding, we don't disagree with each other. I think there's mostly legalistic side points, right? I think we're all. I like your points from Jim and Jeff H.
Right. So Jim, I think is pointing out here that on this explicit one, right, that there should be a third one here. So we can amend these PDFs after the presentation to include the third one. Again, the benefit being this is just tweaking a little Python. Sorry, Tony, what?
I think that's absolutely what we should do. We should not object to that. And since we have this new Python methodology, we can change it in half an hour. Yeah.
Or more to the point, we can tell Martin to change it in half an hour, right?
Literally, Martin can change it in half an hour or less.
That is the beauty.
Maybe first we should, I think there's a straw poll coming about which one of these we prefer, right?
Yeah. Okay, so how many people like the explicit with the amending that there would be 3 flavors here? There'd be an MPI send with an account. MPI send with an int, and then an MPI send with an MPI count, and then an MPI send underscore whatever suffix we land on with an MPI count. How many like that?
I like that one.
1?
I think I like the explicit.
I think I'm tending towards that one.
Yeah, for the user, it's
3?
simpler.
4?
Yeah, I'll go with the explicit.
5?
Yeah.
6?
Yes.
I can't
Or
tell if that
7.
was the same
7.
as 6 or 7.
7.
7? Okay. 7 on that. Then the fake polymorphic, which is this one. We just have 2 MPI sends, one with a count. One with an int and one with an MPI count. Based on the discussion, I'll be surprised if we get any on this one. Does anybody want this one? 0. And then the last one is the token.
I would prefer that.
1. I kind of prefer this one still too.
Yeah.
Yeah, Hammond likes token, but not strongly.
Okay, so that's 4, I think.
I'll change my vote to this to muddy the water a little bit. I'm going to use 6 versus 5.
So with this
okay.
token one, are you going to add MPI send L?
Nope.
Oh, I don't like it then.
Well, keep in mind, we still have okay, so maybe we should defer this vote until after we talk about Annex A. Because how it appears in Annex A versus how it appears out here in the document, different thing, right?
No, I mean, I think users are going to look at this to figure out how to use the MPI interfaces. I think the function should be here.
Okay, so I think we're still at 6 versus 5.
I vote token.
6 versus 6. Great. Split decision. That's exactly what we wanted.
It gives you all the power, Jeff.
Not me.
So,
Our
I mean,
group, Tony.
I can give you like a quick next sort of level of detail since I've been noisy about this. I'm not really strongly one way or the other. I think the thing that makes me a little concerned about having the bracket count here as the type is that we really only want users to call this with 2 different types as that argument. And any other types, I don't know if we're going to, if the user calls this and it's an unsigned int, for example, or if it's a uint32, I mean, are we expecting implementations to figure out how to deal with that type using all of the powers of C11 generic selection, or are we really requiring implementations to only support int and MPI count? Right.
So in the text,
you can specify literal constants that have those types as well. Well, maybe not
Sure.
in 32T, but you can specify, literals that have that don't fit in an int but would fit in an MPI count.
So in the text, we said there are only two interfaces. There's int and there's MPI count.
So yeah, what makes me a little bit nervous about this is just that that users could read this and be like, oh, MPI, I can just put any type there, any number, any unsigned, any non-negative integer there, and MPI will figure out what to do with it. And some implementations will, and some implementations might not. Right? I think we essentially want to specify a generic selection that has two cases in it, and everything else is an error. Like not even a default case. Right? There's an int case and an MPI count case.
Fair enough, but if they don't go read what Waka count Waka means, then they're not reading the standard, right? You have to read the entirety of the standard. I hear what you're saying, but I don't disagree, but I don't really fully agree either, because if they look at that and put their own definition on there without reading what our definition of that means, then that's their own folly.
Yep, that's fine. I'm just saying I like the more, that's the reason why I think I prefer slightly the more explicit
Gotcha.
specification.
I apologize. I'm signing off, so I'll give Jeff my vote. Jeff, Squire, my vote on anything further. I got to go. I'm sorry. I have to go to a PhD exam. Bye-bye.
See you, Tony.
Good luck with the rest of the meeting.
Okay. All right. So that's that one. Back to the slides. Just going to make this here instead of going full screen. Jeff Hammond, are you trying to say something? Sounds like somebody's in terrible reception. Well, to get back in better reception, we'll talk more. If we want the token approach, which we're kind of split on, does anybody have any opinions on what the token should be? Somebody sounds like they're shouting but have terrible reception. Okay, well, whoever that was, I can't hear them anymore.
Jeff, I don't really have a strong opinion, just as long as it doesn't look like a type. So I think that leads to either 2 or 3.
Okay. So some kind of punctuation delineation, and we also picked a different font here, SF, so it wasn't the
something that wouldn't parse in C. Something that wouldn't parse the type in C. So either 2 or 3 or 4, whatever that is.
Okay.
So
Anybody have any other? Yeah.
Sorry, Jeff, this is Puri here. So just to, I'm looking at how the type is defined in Fortran. So there is a bracket, the less than symbol, lowercase type, greater than. That's how it's defined in Fortran since MPI 1. If you wanted how it's defined at other places.
Oh, I see what you're saying, that we have a precedent for this right here, like this.
Yeah.
Right, this, like that.
Yeah.
So in some ways, that makes the bracket, the less than greater than, a little less desirable, because it's kind of like what we did for Fortran, but this has a different meaning here. So maybe the square bracket. So I think Jim's points are probably, if anybody has anything else, I think his points encapsulate this well. Something that does not parse in C and Fortran and is visually different. And we can have a beauty contest later, because the Python will just consistently render it. It doesn't matter.
Jeff, sorry, it took me 5 minutes to read. Can you hear me?
Yes, we can hear you now, Jeff.
Can you? Oh, great. It's been 5 minutes since I was able to talk. Do we say if MPI count is signed or unsigned?
There is a definition for MPI count already. Let me find it. Oh, I don't have that document open anymore. Hang on just a sec. So MPI count is defined, I think, all the way back in MPI 3.0. We didn't make it up.
Oh, no, I know. I'm saying I can't remember. Is it signed or unsigned?
Let's see. In addition, a representative number needs to be a single type. Twice the same width and encode. It does not say. Well, it actually implies unsigned here on line 16. Must be minimally capable of encoding any value that may be stored in a variable of type int. And ints can store negative values.
Okay, because that makes the type promotion rules a little trickier. Anyways, I have to go, but I'll think about this and add feedback offline.
Okay, thank you, sir. Okay, moving on. How do we want it to appear in Annex A? The problem here is that we have two contradicting Annex A precedents. That in Annex A, we currently do show the two different flavors of MPI alloc mem for F90 and F08, but we don't show the underscore F08 suffix in Annex A. And so we, as a working group, didn't know which way to choose. And so therefore, it kind of comes down to what do we want to show? It does not make sense to only show int or only show MPI count, right? We need to either do, well, okay, let's just show the possibilities that we came up with here. Let me quit that. Share again. Okay, and just for reference, this is what it looks like in MPI 3.1. Right? I'm sorry, go back up to this page. There we go. So like bsend, init, buffer attach, detach, cancel, get count, and so on. And in all of these PDFs, we only did the point-to-point chapter, so don't look deeply throughout the rest of the document. All right, in what we called explicit, and again, explicit would need to be amended that we don't have all three flavors in here. We only have 2 out of the 3. But here, notice slightly weird things happen with the alphabetization in that we have bsend, and then bsend init, and then bsend init suffix, and then bsend suffix. All right, but the general flavor is the same. Currently, this example is only showing 2 of the interfaces. We can amend this to show all 3. So 2 bsends, and then a bsend L, and then 2 bsend inits, and then 1 bsend init L. You know, 2 buffer attaches, and then a buffer attach L, et cetera, et cetera. All right, and then following in the footsteps as before, the polymorphic approach.
Hey, Jeff, could I ask a quick question? Yeah. Maybe it's a quick question. I'm thinking about bsend. So you've got the L versions here. I'm wondering if there's a case in the MPI interfaces where you could do something like a bsend init L, where you pass an argument as MPI count, and then there's a query function or something like that that returns a value that you would have given to MPI previously. You know, and you would need to use a function that gives you count back instead of int back.
Yeah, I'm pretty sure that case is already defined in MPI 3.1. That if you do like get elements instead of get elements X, right? But it was a large value. Yeah. I think you get a defined error back. Let's see. So get elements.
We have the we have the request status thing. Those queries those were hard mins for 3.1 or 3.0.
Okay.
I don't think I use them in big MPI, but they're absolutely necessary.
Okay. Yeah, I'm just wanted to make sure that if we're introducing any more cases like that, that they're specified fully.
Yep. All right. So there's this is the explicit one. Here is the fake one that just shows the polymorphic ones, and then we also have the token one as well. So here we go. So back down to just 1, but it has the count token, the Waka count Waka, and so on. And just so you can see, like here's MPI cancel. Obviously, there's only one MPI cancel because there's no count parameters. So none of those were changed, just this. And again, this is all fully automated. right? So it's very pleasing that we have the nice small representation in the tech, and it expands into how you see it in the chapter, and then how you see it in Annex A. Okay. So when we get to slide 15 here, it really is pretty much, it really is pretty much exactly the same as, how do we want it to appear in the text? We have the same options here, and how do we want it to appear in the annex? Now, can we have some discussion here? Here's a question. Would people want to see, say, a token-based approach out in the text and then see an explicit type of approach here in the annex? Or would you prefer to have an explicit in both out in the text and in the annex?
I think it definitely has to be explicit in the annex, no matter what we do in the other part.
Okay.
Yeah, that's what I think too. It has to be explicit somewhere, and so at least in the annex.
All right. Now, how about the contradiction, though, that we don't, in the annex, they don't elucidate the underscore FO8 suffix? Because that is a contradiction.
No. The annex needs to be the annex needs to be complete. Everything.
No, I'm sorry. What I'm saying, Jeff, is that in MPA 3.0 and 3.1 and whatnot, they don't list the underscore FO8 suffixes at all. They only list what the user can call, I guess is the way to say it. They don't list what the symbols are. So maybe that's not a contradiction.
I think Jeff is saying that's an errata and it should be fixed as part of this change.
Well,
I'm not sure it is because that's not what you call from Fortran. What you call from Fortran is MPI send. You don't call MPI send. Wait, you don't even have the option to. Right, and so if we list the three things in the annex that the user can call. Actually, that's very different then, because in C you will have three options, right? Yep. In Fortran you will have two options, right? Because we don't have this C11 generic selector in Fortran. It's much closer to overloading it like it is in C++. It's a little different, but for purposes of this conversation, it's the same.
I guess the question we need to answer is who is each of the pieces of this document aimed at? I think the main text is aimed at users predominantly, and the Annex A is predominantly aimed at implementers and tool writers. If that's really true, then the Annex needs to be explicit about what are the symbols that I need to support as an implementer, and what are the symbols that need to be present as a tool writer and exposed to tools and so on. That needs to be explicit and have all of the FO8 binding, symbols and all of the C binding, C tool, symbols and so on. Everything fully explicit, and it's an error that it's an errata or whatever. It's an omission that has never been done before. Right. The main document is aimed more at users and how you use the thing, and so it should be the ones that you can actually call as a user, and therefore will be different. It won't have the FO8 underscore FO8 on the end of things because you can't explicitly call that. That would be a good justification.
Hold on. Does this mean we need to put all the PMPI symbols out there too? In the annex?
Possibly.
I mean, the annex today has never been what are the symbols. The annex is what are the interfaces that you can call.
Yeah. Okay. So I guess that's my question: is if we define what the annex is for, why does it exist? Right? We're not just publishing this because we want to kill trees. We're publishing it because it's useful for somebody. Who is that somebody? If that somebody is a user, then we shouldn't put the FO8 symbols in because they can never call them. If we're targeting it at implementers or tool writers, we should put them in because they need to know those things exist. That's the decision point to me.
Yeah, I guess I see that.
So
I see
based on
underscore
the current
FOA.
standard, it is for users and not for writers.
I guess I see the underscore FOA as being a little bit different and nuanced, whereas there's really never been anything. I mean, I don't care if we do it. I just think that's a separate ticket, something completely independent of this.
Okay, Jeff, your audio broke up a whole lot. I think you were saying you didn't care too deeply and it could be a separate ticket. Is that what you were saying?
DMPI should be a separate ticket here. Just take it out. I don't want to discuss it. I think it's just a second for what we're doing.
Okay. Well, we still have a separate question then, though, and maybe it needs to be split in half. What do we do in Annex A for the C bindings, and what do we do in Annex A for the Fortran bindings? Right? If we go explicit, that actually has two different meanings, because in C there would be 3 listings, and in Fortran there would only be 2.
So technically in Fortran, it would be an interface with 2, procedures.
Right.
A generic interface with 2 procedures. That's the correct way to do it in Fortran.
Okay. Well, let's take a straw vote with that understanding. So explicit means in C we would list the 3 interfaces, and in Fortran we would list 2 interfaces that are part of a larger. I'm sorry. Yeah. 1 interface with 2 procedures in it. Sorry, that's the right way, right? Puri, thank you. Okay, and then fake is the polymorphism one that we showed, and token would be the token-based one that we showed, right? So, how many people would like explicit?
I would go with explicit, at least in
1. Just the 1?
2
Yeah, no,
for me.
yeah, 3.
3. Okay.
4. I think I prefer that too. I think that's
4.
5 and 6. I spoke over somebody.
No, 4. That was me saying 4.
I'm 5.
5. Okay, a couple people have dropped off, so I'll call that 5. How many people would want the fake? Like 2 flavors of MPI send and nothing else? Kind of assuming that's going to be 0. Yep. Okay, token. Who wants the token based? Okay, also 0. Okay, good feedback. Thank you. Last question, and then we'll actually get to the text.
Jeff, here's the thing. So it has to be explicit, but this.
Oh man, Jeff, I'm not hearing you. You're dropping out.
Oh, fucking hell, dude! Fix your WebEx.
Well, that one came through.
Okay.
Try again, Jeff Hammond.
Can you hear me now?
Yes.
Okay. So AT&T sucks. I'm on the freeway now. So.
Okay.
The edit has to be explicit if we do token, because the fact is, at some point in the future, stupid people like me and anyone else I like argue with have to have a stupid argument about what the symbols are, and so they absolutely have to be explicit somewhere so that stupid argument lasts less than a minute.
That's a good point. Martin, make sure you get that point down, please, in the feedback. To prevent future arguments is actually always a worthy thing.
We have another quick question too, thinking through.
Yeah.
There was a question about the profiling interfaces here. Are there generic selection versions of the PMPI functions?
I don't think I did PMPI in Fruzil, did I?
They really shouldn't be there actually.
That's
right? I think it
really
makes things a
good
lot harder
point.
for tools.
Well, so here's the thing. That makes a dichotomy between C and Fortran, which might not be a bad thing, but let's just walk into this with our eyes open. Because in Fortran, well, actually, wait a minute. So all right, let's talk PMPI in Fortran. So today, you would make an interface and have two procedures in there for MPI send, right? But if we don't want to do that in Fortran, we would just have two Fortran subroutines, not inside of a single interface, right? There'd be MPI send and MPI send suffix. That's what you're talking about, right?
So if I just to make it a little more concrete, I mean, if I'm writing a tool and I'm in the MPI send function with the int count argument, then I know the type of the argument and I don't need generic selection. And I should be directly calling the PMPI send with the int argument or PMPI send L with the MPI count argument.
Okay, so on the C side, that just means we don't have the C11 generic selector for the PMPI functions, which I think is fine. And on the Fortran side, it means we don't have interfaces, we just have naked subroutines, which I think is also fine. I think. Need to think about that a little bit, but I think that seems like your use case seems pretty good. You should call that out.
Okay, so Squires, so I am very much in favor of not having polymorphism in the PMPI because I just don't see the use case. I do not see a good use case, and I think people who are at that level should be explicit. However, I worry about the possibility that there is some user out there that foolishly believes that symbol interposition introduces prohibitive latency into their code, and they've got some stupid option where they pound define or whatever, MPI to PMPI, they swizzle that and expect it to work. I don't think that's good, but do we want to break such a workflow if it exists?
Yeah, I hear what you're saying. I don't think I would shed any tears about breaking that.
That's fine. I
it's
agree
a good
with
point,
you.
though.
I just want us to say that. I want us to explicitly agree to break that dumb use case rather than forget about it and then feel bad later.
Well, we don't have to break that use case if we put a feature selector on the MPI header to take out those generic selection macros. Right, there's still a path where that will work.
Yeah, no, I think what Jeff Hammond is saying is if someone is going to assume that there's polymorphism on the MPI side, are they going to also assume that polymorphism is on the PMPI side? And I think we're saying no, right?
What I'm saying is they should not assume. They should not. Even they can,
right.
But they're wrong.
We should punish them if they do assume such a thing.
Exactly.
Yes.
Yeah, I was thinking of the other problem that they'd run into first, which is that it won't even compile because you'd be redefining a macro.
Yeah. Oh, there is that too. Yeah. In C, at least. Okay, let's get on to the last one because we haven't even gotten to the text yet, and we're an hour and 15 minutes in. The last one is, should we also do displacements since we're monkeying around with the bindings here? Should we just do displacements and counts at the same time? Honestly, this is just tweaking Python for us. But if we tweak this once, it's a whole lot easier to change both at the same time, especially in terms of implementation, because the C11 genericness will get crazy complicated if we change just count today, and then in MPI 5, we change displacements.
Okay, Jeff, this is literally the most important thing that I learned when I did the big MPI stuff. We absolutely must fix displacement when we fix count. If we don't, we end up with a stupid pile of steamy, shitty garbage. Okay, this is the biggest hill I will die on. I will die on it quickly and repeatedly. We must fix displacements if we don't want to be really, really stupid and feel sad forever.
So when I made this slide, I was really praying that you were going to be on here, Jeff, because this was just a volley for serve to you. I completely agree with what you're saying, that we kind of have to do this or we can't fix displacements in the future. Is anybody violently opposed to this? Let's also fix displacements at the same time? Okay. Good.
Jeff, I have a follow-up to that. So should it be MPI int or should it be MPI count?
I think we decided MPI int, didn't we? Because the displacement is an int.
We did decide that partly because Austin didn't say it.
For consistency, it should be ANT. But I personally hate what we did to count because of this stupid MPI offset file IO 128-bit nonsense. But yes, it should be ANT. It's an offset into a buffer. It shouldn't ever be 128. It needs to be
that's what
a memory
MPI
offset.
3.1 section 256 says, that displacements are supposed to be MPI address kind and MPI ANT.
So the text actually assumes that it's an int. So I just wanted to make sure that, there's not a, miscommunication that people are expecting it to be a discount.
Okay. Well, in typical MPI forum fashion, it took us an hour and 20 minutes to get through 16 slides. Thank you for all the feedback. We will incorporate all of that. Now I'm going to turn this over to Puri. Puri's going to show some text. And remember, the goal here is to get us ready for September. I think we've got a lot of feedback from you already that obviously is not going to be reflected in this current text. Like, for example, we show the token approach in here. And we also assumed _L. So take that in stride here, and let's not spend our remaining 40 minutes on that. Let's just talk mostly about the content and the concepts.
Okay, can everybody hear me okay?
Yep.
All right. And
thank you for making that larger. Perfect.
Yeah, and is this the right size?
Yep.
Okay. So I'm just going to go over some of the text changes that we have proposed. Obviously, this is going to actually change based on some of the discussions that we have had today, but just want to give you an idea where we are planning to add this text and what we are planning to add there. And of course, well, after this call, I will get together with, Jeff and Martin and Dan and Tony and try to make that reflect what we agreed upon today. But so in the count section, so we already have this text which defines what a count is, and also there is a rationale. So the current rationale, there is currently a rationale which includes this particular sentence, and we changed one of the sentences after that, and basically added that in prior version of the standards, many MPI routines use int in C and integer in Fortran as the type of count arguments. To avoid breaking backward compatibility, this version of the standard supports both int and MPI count in C, as well as integer and integer kind equals MPI count kind in Fortran in such routines. See section 18.2 for details. So the 18 is the language binding section, so that's where more details will appear. And we also added a note that the standard refers to the polymorphic use of both the C int and MPI count, and the same thing in Fortran by the shorthand large count, because we use large count in the text. So we wanted to make sure that when we say large count, what it refers to is really using MPI count or the integer kind equals MPI count kind when we're talking about that. Okay. Does this?
Minor question on the text.
Sure.
On line 24, why use the word logically?
That's already there. That we didn't change. This is what was there before.
All right.
I don't know why.
It's fine then.
While we are at it, we can fix it. So
there's just 3 words where there could be one, but it's fine.
yeah, I wonder why logically is there.
I'd say count values must be large enough to encode, etc. If you did want to change it, but again, you don't have to. It's already there.
All right, I'll just highlight that and figure out who added it and why they added it. Okay.
Yeah, I think this was a victim of the LaTeX macros. Those first 2 lines of the rationale are identical to MPI 3.1. So count values logically, blah, 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 type views and file views, etc. That's verbatim.
Yeah, I know, but I think in a sense, since we are fixing this anyway, should we go ahead and just say, count values
I don't,
must be
I
large
don't have
enough?
an opinion.
Okay. All right. Okay. All right. Anything else? All right. If not, then moving along further down in the section on Fortran language bindings. So we added these 2 paragraphs. The support for large count and displacement in Fortran is available only in the module MPI F08. Users using MPI.h and module MPI will only have procedures with type integer for count and displacement values. But looking at the interfaces that Jeff has generated, this is not true. Jeff, you have generated even the large count values for MPIF.h also. So was that an oversight, or did you really mean to do that?
Shit. That was an oversight. Okay, there's a bug for me and Martin to fix.
Okay.
Good point. Thank you.
But the text is correct, right? So it's just that.
Yes, just the intent is to only do MPI F08.
Okay. I noticed.
Kind of a carrot and stick to get people to move up to the better Fortran interface.
Yeah, and the previous sentence says that are inconsistent and
Yeah.
So okay, all right. So then the next part basically. So again, here we went with the assumption that we are going to go with the token approach. So if we go with the token approach, then the type of the count arguments are specified by the token count. And again, for now, we are going with that. The possible values for count are integer or integer kind equals MPI count kind. Similarly, the type for displacement arguments are specified by the token displacement. The possible values for displacement or integer kind equals, well, this would be address kind. So I know Jeff added this, so that's address kind.
Oops, sorry, typo.
If it's going to be int, then it would be address kind.
Yeah.
Okay. All right. Okay. All right. And that's all we are saying about the Fortran bindings, at least in chapter 2. Any concerns, questions? Okay, if not, now moving to the C bindings. So we again have a similar statement here. The type of the count arguments are specified by the token count. The possible values for count are int or MPI count. Similarly, the type of the displacement arguments are specified by the token displacement. The possible values, okay, I guess that would be.
Yeah, and this will all be changed if we're not going to go the Fortran.
Yeah.
Yeah, and I got MPI count there too. Sorry, copy and paste error.
Yeah.
But we're gonna have to tweak this to I think the direction of this call is leaning towards the explicit.
Right.
But the concept is the same here, saying that count arguments, there will be multiple types, etc.
Right. So something unrelated to what I was planning to show, but since I noticed this section, so this is what the current standard says about function and macros. So, we were discussing about this earlier. So this may be something that we want to keep in mind. And now we are using generics, so maybe we may need to say something about that here. Would generics fall under this particular section?
Yeah, they absolutely do. I mean, if you have the generic functions, they're implemented as macros in C.
Right.
Agreed.
So there should be something
We
written
need to
here.
say something here.
Yeah. So I thought when we were discussing about that, particularly if we go with the option of providing, backward compatibility with C89 and macros are the way to do it there, then we need to say something here.
Hey, I had a quick nitpick on the previous paragraph too. If you decide to keep this text, I mean, I realize you might change it, but
Sure.
instead of saying the possible values for count, would it be better to say the possible types for count?
Okay.
Yep.
Yeah. Thank you.
Same thing in the latter half. I think it's probably all going to go away, but it's a valid correction. Yeah.
Okay. All right. I believe that's all in this chapter and in the language. So we added a separate section. So I don't know whether you all can see the table of contents here. The language binding section had, Fortran support and interoperability, language interoperability. So we added a new section called support for large count and displacement in MPI language binding. So, I know Jeff asked this last question. We assumed that we are going to do displacement, so we went ahead and added this text. MPI uses language polymorphism features to support multiple types of count and displacement parameters in many MPI procedure calls. So again, the rationale for why we are doing this. Prior versions of the MPI standard use the cint and the Fortran integer times for count and displacement parameters in many MPI procedure calls. These types have been deemed too small to hold values that application wish to use. In order to not break backward compatibility with existing MPI application, the MPI specification uses language polymorphism to allow both the original int/integer types as well as larger types for count and displacement parameters. Okay. So again, depending on which direction we go, this would change, but this is what we have. Each procedure call in MPI 3.1 has default integer parameter types for count and displacement parameters parameters now support two interfaces, one interface with the type parameter.
Corey, can I interrupt you for just a second? So
sure.
Just right before he reads the section, there's a reason for this little disclaimer language in 17 and 18, because don't forget that we have the _x functions in MPI 3.1 that already use MPI count for the count types. And we also have non-blocking collectives that use MPI AINTs for displacements. And so this language is specifically trying to be clear about the old ones that were broken, not, the ones that are already good. So I'm sorry, Puri. I just wanted to make sure that people.
Yeah, I should have mentioned that, but thanks.
Can I ask about the usage of the word default there?
Yeah.
Sure.
Yeah, I mean, so that has a specific meaning in C11 generic selection. Is that intended here?
No, we were just going for int and integer. If you, who knows better about languages, say that the word default there is bad, then let's just take it out.
I think it would. Well, so we should specify if there is a default clause in the generic selection expressions, but it's probably better to take it out here.
And you're right. Right now, we didn't even think about the default clause, and we don't say anything.
Yeah, we got that. Martin took that note earlier that we need to say something about the C11 default clause. There's nothing in the text right now, but we got that note.
Yeah, my preference honestly is not to have it, and just to let it fail at compile time if you don't match one of the other types.
Yeah, we're going to break a lot of codes that way, though. I mean, I think that's going to be a deal breaker.
Well, then, yeah, I mean, maybe we should have a longer separate discussion about this, but then what you really want to do is you want to put the other types into your generic expression, right? You don't want to cover all that stuff with default. Right? If you want to support, an unsigned literal constant being cast into the function, for example, you should put that type in the list. Right? So all the types you want to support should be in the list.
I mean, that's what they're calling today, though, is like if they pass an unsigned, it's getting converted to an int.
Well, it's bad programming.
Right word. It's bad programming, but
and the compiler should be warning you about loss of precision.
It probably is, and they're probably ignoring it, right? So they should get those same compiler warnings, right? If we have the default clause that promotes back to the int, the old int version, right?
Or we can fix the bug for them and instead call the MPI count version.
Well, that's my point. What should
put
the
unsigned in
so it's
put
two
it
questions,
in the
right?
list and call the right function.
So in Fortran, you will be swiftly punished, right? If you call with a non-integer, right? If you call with int star 16 or whatever, it won't compile, right? Because it's stronger types than even C++. In C is where we only have this problem, and today they're all getting promoted to ints. So it's two questions, I think. One, do we have the default clause in the C11 generic? And two, if we do have it, which one does it point to, the int or the MPI count one? And the problem with promoting it to the MPI count one is where it's an out variable, right? That's why in Frusel it promotes, the default always promotes to the int one.
If it's an out, meaning you passed the pointer with the wrong type, I think that we should not have a default. The user should get an error there. There's no meaningful type coercion that should be happening.
But what if they pass a uint, right? And they know the count is always less than 50.
Mm-hmm. Then they should be punished for writing bad C code. I mean, come on.
Yeah, well.
Because this is an assumption, right? I mean, does the C language specify that the unsigned integer and the integer have to have the same? They don't have to have the same representation. Do they have to be the same size?
For the 80% of users out there who are just writing bad code, there's 20% out there who are sticklers saying, yes, I know it's an unsigned int, but because of the logic of my program, I know for a fact that the value I get back is going to be representable fine in this uint.
C's type system already can't stand up for itself. I think we should help. I strongly, you should not be writing code that abuses an already abused type system. If it doesn't match one of these things, it really should be an error, and users should be encouraged to fix their code.
Yeah. So
please take the feedback.
Yeah. So
let's just have Martin take the feedback here, and we're gonna have to offline this because we still got 20 minutes and a bunch of text to go through. So Martin, the feedback here is one,
definitely one to focus
should
on.
we have C11 generic default case?
Yeah.
And two, if we do, what should the default be? And three, that answer may be tempered based on whether the count or displacement is in or out. And I think we'll have a longer conversation about that.
Yeah.
Right?
Yeah. Okay. All right. So thank you. Thank you, Jim. Thank you, Jeff. And thank you, Martin, for keeping notes. I guess he can't say yes or no.
Oh, he's texting me. Don't worry.
Okay. All right. All right. So continue along. So yes, this default, we didn't mean the C default here. So we basically I think we'll just get rid of that and say that.
Just strike that word. Yeah.
Yeah. Integer parameter types for count and displacement parameters now support two interfaces. One interface with the same parameter types in the procedure definition as defined in the current standard, PA 3.1, usually with int and integer parameter types. Another interface with all count parameters defined as type MPI count in C and integer kind equals MPI count kind in Fortran, and for display and all displacement types defined as int in C and integer kind equals MPI address kind in Fortran. Okay, these are the only two interfaces that are defined. Okay, and obviously based on whatever we decide with the default case, then we will probably add text to say that, which will be the default case. Okay. That is to be done. And then there is a following advice to users. Some MPI procedures that have multiple count and or displacement parameters. In such cases, all of the parameter types are either exactly okay, looks like we made some
Sorry. Exactly. I think as they were defined. I think is supposed to be as, yeah.
As they were defined in MPI 3.1, or all have been upgraded to MPI count or integer equals, count kind, and a int and integer kind equals MPI address kind. There are no interfaces where some parameters are still the default. Well, I guess again we got to get rid of that.
Yeah, well, there's the word default again. I just love the word default. I like typing it.
Integer types and other parameters have been upgraded to the logic types. Okay. So basically what we are really trying to say here is that, we are not doing mixing and matching of old and new. It's either all old or all new. There is no new and old or old and new. Any concerns with that? Okay. Then here we have the text, and obviously this will all change depending on the discussion today. But whatever we decide, we will say something like this: to support profiling and other tools, an MPI implementation shall provide two distinct symbols for these polymorphic functions that have count or count offset kind arguments.
I don't think that's offset kind. I think that's a mistake. Yeah.
Yeah, that should be okay, count kind. The new polymorphic interfaces introduced after 3.1 must append _L, lowercase l to the end of the C symbol, and append _L _FO8 at the end of MPI FO8 module symbol. Okay, so this is the node for the tools. So this is what the symbol should be for tool developers and tool writers. So we are just trying to make sure that there is a well-defined symbol. Okay.
Yeah, and the exact suffix, I don't know if we came to a complete conclusion on what that should be, whether it should be L or X.
I think it was more towards X than L.
It was leaning towards X, but it means breaking backwards compatibility. That's the consequence. And if we're okay with that consequence, fine.
But Jeff, I was thinking about that. That can be solved in Fortran. So the interface, don't provide two, just provide one in the interface, and the second one already exists.
Okay.
So I think we can get around that in Fortran.
Okay. All right. We'll take that offline. Cool. If that's solvable.
Okay. All right.
Puri, I have just a small remark. I just checked about the last phrase in the advice to users. I think I get what you're saying. It's just that there is no interface when you are just updating some of the parameters and not other ones. But as it turns out, if you read it, it's saying that there is no interfaces with some integer types parameters and, for example, MPI int parameters for displacements. But there are in MPI 3.1. So.
Yes, there are two exceptions that, one is the nearest neighbor all to all W and the corresponding persistent collective init for that. So these are only two ways that exception. So should we, I had added that exception, which I think Jeff took it out. Should we say that these are the two exceptions? Or
yeah, I'm sorry. What are the two functions again? I saw that and I was confused.
Neighbor, it's the iNeighbor all to all W, and the corresponding iNeighbor all to all W init. So basically, these two functions use the aint for displacements. That's the only exception in the standard, whereas everywhere else displacement is always an int.
Yeah, I think that's okay. because we're saying that if, exactly what it was in 3.1, which already used MPI ANT, right? And so it's either what it was in 3.1. That's the intent of what we're trying to say here. Maybe we need to tighten the language up a little bit, but say it's exactly what it was in 3.1, or it's been fully quote unquote upgraded.
Yeah.
And if we didn't quite say that, then we can tighten that up.
Yeah.
Go ahead, Julian.
But actually, I'm hearing a different thing, a different concern that you might be correct on. And maybe this is what you're saying already, is we just said integer types. We didn't say count and displacements here. Oops.
Yeah.
We didn't upgrade rank parameters to
MPI
count.
Yes.
Yeah.
Yeah, it was first my point, but it's a really good point.
Yeah. Martin, please make sure to note that this was Jeff's hasty edit this morning that I didn't quite get that right.
All right.
Thank you.
Okay.
Whoever said that.
Thank you, Julian.
I think that was Julian.
Okay, all right. That was a good point. Thank you. And this we will fix based on whatever underscore X or whatever we decide. Okay. And then we have two separate sections, one for large count support in displacement in Fortran and then in C. So for the Fortran, we say that the generic interface feature in Fortran could be used to implement the polymorphic interfaces required to support large counts and displacements. An abstract interface is defined for procedures that use count and displacements as parameters, and two separate procedures are defined. One of these procedures shall include the subroutine that supports the type integer, and the other shall include the subroutine that supports the type integer kind equals MPI count kind and or kind equals MPI address kind. Okay. So this is really for implementers in terms of how to implement it. Okay. And corresponding text for C. A form of polymorphism that has been supported in ISO C via the generic features since C11. A form of polymorphism has been supported in ISO C via the underscore generic feature since C11. If a C compiler supports this feature, then the type of the count parameter shall be polymorphic and shall be either in for backward compatibility or MPI count to support large count values. Similarly, the displacement parameter shall be polymorphic and shall be either in for backward compatibility or in to support large displacement values. However, based on this discussion, we may want to, expand upon this and say, if you decide not to use the generic feature, what you should do. I think we should spell that out since we discussed that, which we haven't done here. And this is just a note, particularly, since generic is not supported in the C++. So this is an advice to implementers saying that even though we don't care about C++, this is just kind of a, hey, be careful. Since the C pointers were removed, MPI no longer provides explicit support. However, it is common for MPI implementations to provide support for C applications by carefully crafting MPI.h include file so that it can be used in C++ compilation units. Since the ISO C underscore generic feature is not part of the C++ language, implementations wishing to have an MPI.h that supports C++ must choose an alternate implementation path.
Oops, sorry.
Yeah.
minor mistakes there.
Yeah, so something didn't go right here. Such as C++. Basically, we are saying that, hey, you can use C++ function overloading if you want to, but this is outside the scope of MPI specification.
Yeah. Now, note that this has a consequence for tools, though. That if you're a C++ application and you call one of these polymorphic functions like MPI send, that has deep implications for tools that intercept. But we don't support that because we don't support C++. That's kind of a big point, but we're we really don't want to, use this ticket to sideways introduce C++ back into the standard.
I think C++ users they're not going to get, unless there's an extension in their C++ compiler, they don't get under generic. So they're either going to call the baseline MPI send, or they're going to have to call MPI send _L, right? They don't get polymorphism. Right. That's one of the reasons why I think it's so
way to look at that. Actually,
those functions.
Yeah, that's actually a really clever solution. If we go the route of what was discussed earlier in this call, that if your C compiler does not support _generic, then you got MPI send and MPI send L. You just don't get the generic selector.
Right.
Maybe we should treat C++ like that. Well, you can call MPI send and MPI send L. You just don't get automatic polymorphism. That's actually a really clever in here.
Yeah, we got a little bit of language in the OpenSHMEM spec that you could lift for this that has the specific language versions and stuff. Right, the specific, ISO standard version where it was introduced, all that kind of stuff. But if it's available in your translation environment, we will provide _generic, and you can call it. If it's not available in your translation environment, then you don't get to use it.
Puri, Dan, Martin, what do you guys think? I actually really like that solution.
Yes, I think that sounds like a good solution.
Yeah, I think so.
Okay. Martin, please note that down. That's a nice, clean solution.
Okay.
I got another wrinkle for you here, though.
Sure, go ahead.
Oh, I love it. Just bring them on, Jim.
Let's say I am. Let's say I have an ABI where int is 64 bits, and so my MPI count is exactly the same type as my int. Okay. And in this translation environment, you will not implement the _generic macro, or I submit to you that you would not implement it because it doesn't do anything. And in fact, you can't implement it if those two types are compatible. You can't put both of them in a generic selection and expression.
So you're saying we should have sorry, your audio cut out for me, but I think that was my end. Are you asking what happens when int and MPI count are the same size and the same type?
I guess so I need to reread the text again, and maybe I'm just trying to give you guys a to-do item just to reread this text and make sure that it still is consistent in an implementation where that's the case.
That is a very good point. Yes, Martin, please take that note that we need to make sure that if int and MPI count are the same, sanity still occurs.
Right, yeah, keeping in mind that an implementer for such a platform can support all of the MPI interfaces as defined here without needing to provide the macro.
Right. So they could just, type def their MPI count to int and it still works. So they don't have to do anything.
Well, if they have a big enough int, because we do have their MPI does make restrictions on what MPI count must be.
Right, but this is the case where int and count are the same, right?
Yeah, if they have a giant int is really what it is.
Yeah.
Yeah.
I mean, 64
bits. I guess
it's reasonable size.
Well, yeah, but default. Yeah. Sorry, wrong.
Yeah, I mean, let's not assume the world's going to stay LP64 ABI forever. Right, and in an environment like that, you actually cannot write a generic expression for this because the two types are compatible with each other, and so I would have an MPI send that takes, I don't know what type I put there, int or MPI count, it shouldn't matter, and then I only have two of the functions. I don't have the third one.
Mm-hmm.
Right.
So one of the comments that Bill made to me at ISC was that should be the natural way, that was intended to be the way that large count would have been supported, because int is supposed to be defined by C as being the natural size of integers on the system. And so that should be the size that MPI should use. And if it's not the natural size of integers on the system, then, basically, when the natural size becomes 8 bytes, then int should be an 8-byte quantity. It should be stored in 8 bytes, and the language should do that for us. And then MPI still using int is fine because we're using the natural size. I think the counter argument to that is that some of our MPI users want to send things where the size is specified with an unnaturally large size. So int is not big enough, even though the natural size of things, the other sizes are provided because sometimes you want to send something that's unnaturally large. But
I mean, if you want to get picky about the language, though, Seed actually does have a type for sizes. We're just using the wrong type.
Yeah.
Yep.
I agree with that as well. Yeah.
Okay, all right. So that's pretty much what we have in terms of text updates. So do folks think of anything else that we need to say anywhere that we have missed? I thought these were the only 2 sections where we would, talk about these changes, the semantic terms chapter and then the language bindings chapter. And of course, all the bindings, they would appear based on what Jeff showed you and the corresponding appendices.
Yeah, don't get us wrong. We're touching the entire document, but this is the only text we're changing.
Yeah.
So I think I have a comment. If we're really going to expose the MPI send suffix things for users to call directly, then I think we should have a sentence in there saying that if you explicitly call the large count version of this function, then if you wish to get, for example, the MPI get count to find out what the count is of a request, then you must call the suffixed version of that as well, because otherwise it won't work. There'll be a down conversion potentially. MPI, you're forcing MPI to do a down conversion, and I think we should have a sentence in there saying if you. So the common usage is I do MPI receive or a probe or something, or I do whatever. Let's say I receive with a wildcard, and then I'm asking a count, MPI get count, how many things were there, so that I can then do something, maybe allocate a buffer or something if it's probe. So if I called receive L, then I should also use get count L, because using get count, well, we could define that to work, and it would just, it would try and downcast it, and either cause an error if it doesn't work, or lose precision if it doesn't work, or something. Or we could just say explicitly that's not allowed. If you've done receive L, then you must do get count L.
I don't think we have to say it's must be disallowed. I think if you get an error from get elements or whatever because it lost precision, then that's your fault. I don't think we have to. It's just like we don't have to match MPI send L with MPI receive L, right? It's only the underlying type map that matters.
Yeah, that was my
question. That's a different thing because yes, then you're right that the type map just has to match. I think the other question is a different one though, because it isn't possible to represent all the values that your input in the output that you're supplying. It is possible to represent them in a different way between the send and the receive side, and so you can get away with that. It's a type map that really matters. As long as you specify the type map, I don't care how you do that.
I know, but you could also MPI send L 5 elements, right? And 5 MPI ints, right? If just every time you use MPI send and MPI receive, you're actually calling the underscore L ones. You could call it with small values. I don't think we need to overspecify that by saying you're not allowed to, because there are definitely cases where it would be perfectly valid to do that.
Mm-hmm. So we would have the implementation check if there's loss of precision before returning the value.
We need to go look at MPI 3.1, but like Jeff Hammond said earlier, I'm pretty sure we defined that you'll get an error back if you lose precision, or something is handled properly. And I know for a fact that, like, for example, in both MPitch and OpenMPI, our internal representation of the count is 64-bit. And so something already happens if you call, for example, get count with an int and it's too big.
Yeah, I guess that
I'll tell
error
you what,
would have worked by default.
Yeah, let's take that as a feedback that we should go investigate what happens there. I hope that was already taken care of in MPI 3.1.
Yeah, I also hope that it isn't a fatal error, and I hope that I don't have to set my error handler to errors return in order to stop it killing my whole job.
Well, if you really wanted to not kill your whole job, you should call get elements X.
Yeah.
I'm sorry, we're almost out of time, and I have one more clarification I want to get from the group here. So we talked about going the explicit route so that in C, people can call MPI send with an int, MPI send with a count, or MPI send L with a count. In Fortran, what is the goal? Is the goal that you can only call MPI send with an int or a count? Or do we also have to have an MPI send L in Fortran where you can only call with a count? I'm sorry, X, whatever the suffix is. It seems to me that we're doing the thing in C because C11 generic sucks. But in Fortran, it's better. And I don't think, my personal opinion is that we shouldn't force this wonky thing on Fortran because the Fortran language in this aspect is better than the C language.
But Fortran has been used as a way to force wonky things onto the C interface in the past, so I think we should get it back.
On the one hand, that's damn funny. On the other hand, I don't know if that's a good reason.
It sounds like a reason that might carry the day, though.
I go with just that I really like Dan's comment.
Jim Dinan, do you have an opinion here since you've been outspoken on this call?
Could you restate the question? I missed it.
So in C, we're going to have the three interfaces, right? We're going to have MPI send with int, MPI send with count, and MPI send suffix with count, right? But we're really doing that because C11 generic kind of sucks, and the language isn't really that great here. The question is, do we need to do that same thing in Fortran where the language is actually better in terms of interface overloading? Do we need to have an MPI send with int, MPI send with count, and an MPI suffix with count?
In Fortran, I suspect you have the same problem if the int and the count are the same underlying type. I mean, you have that problem with C++ polymorphism.
No, that's not the issue here. Do we need to expose to the user that they can call MPI send suffix in Fortran?
I mean, I would.
Right, because we're
there, but
we're exposing the suffix in C because the language sucks, right? We don't need to do that in Fortran because the language doesn't suck in this aspect.
I agree that generic sucks, but also, I mean, if you want to be compatible with C++, or if you want to be able to use like Python bindings, for example, or anything else that's going to want to touch these C bindings that doesn't, where you're outside of an environment that, that supports generic, it's just a brittle feature. I don't really know anything about Fortran.
Okay, you don't have an opinion on the Fortran. So this is a Fortran question for me. I'm already sold on we need to do all three for C. This is really what should we do with Fortran? Does it have to be three or can it be just two? I think it should just be two.
Yeah, it's really two because the way you do this is you define an interface and then the interface has two methods. So there's really only two. There's really there is no C equivalent for that, right?
Right. That's what I'm saying. Is this will now be a difference between C and Fortran.
Right.
That C will have three ways, and Fortran is only going to have two, and you're not going to be able to explicitly get the count one unless you call with the right type of parameter.
That's correct.
I mean, Is it meaningful for tools to have more detail in the Fortran part?
I don't think
see something different.
So whenever we talk to the tools working group, they're like, we write everything in C. We don't write it in Fortran.
But I'm sure that they still intercept Fortran calls.
They do, and as long as we give them the predictable symbols to intercept, that's fine. But before, we were talking about more than symbols. We were talking about what the application is allowed to explicitly call, right? That's different than what is the symbol.
Sure. Well, I sorry, I got to drop. I trust you to figure out the Fortran part.
Okay. All right, then I think we're going to go with what Puri and I agree on, that it'll be 2.
Okay. All right. Any other
Hey,
comments
Jeff?
before we, okay, go ahead.
Yes, sir. Someone, was that Tom?
Yeah, just quick question. Does this have any bearing on the other older interfaces for Fortran? Would it help them in any way having the explicit case?
We don't want to do the older
For the people
Fortran
using-
ones at all. We only want to do FO8 because it's kind of a carrot and stick saying you should really be using MPI FO8. If you want big count, use MPI FO8.
Okay. I didn't know if there was some benefit to them. Okay.
There is, and don't forget, you may not know that in the you can upgrade like one subroutine in your legacy, 5 million line Fortran code to use MPI FO8. It does not. You don't have to convert your whole program to MPI FO8. You can say, oh, I need big count in this one place, so I'll upgrade just this one little area of my program to FO8, and it still completely interoperates with the rest of my application. We're very careful in the design of MPI FO8 to allow that.
I remember you clued me in this last time. I already forgot. Sorry.
Well, you are forgiven for not remembering squat about Fortran because honestly, who wants to?
All right.
All right. Any other comments, or anything we missed that, we need to clarify or add or anything else? Okay. All right. Jeff, I'll
Everybody,
give it back to you.
I am going to stop the recording. Thank you, everybody, for your time today. This is all really excellent feedback and will really help us prepare for the Europe meeting in September.